Hello and welcome. In this tutorial, we are going to study about object class in Java. This is the most important class of Java and thereby I have decided to cover it in a separate tutorial. So let's begin. Well, object class is a superclass of every class. That means each and every class actually inherits from the object class. Now, this is the topmost class in the hierarchy, and each and every class falls beneath it. Because it's a superclass, therefore, it can be used in upcasting, and it's really beneficial to use it if you're not aware of the actual class name. Then you can even upcast it to object, as object is a superclass of each and every class. Thus, every class inherits the object class method and can even override it. Some of the object class methods are clone, equal, hashcode, toString, finalize. Some others are wait, notify, notify all, and wait to have three kinds of versions. But the other methods are like get class also. Now object class is having a simple plain constructor which do not take any arguments. So it's a default constructor. So in order to initialize anything with the object class, you can simply create using new object and you do not require any parameter into that because object class take a no argument constructor, that is the default constructor. So first of all, let's see the clone method. Now, do you recall that while studying the operators, we studied equals to operator, which actually simply copies the object reference. For example, we have created an object student S1 equals to new student where we pass Meth, Gym and 3.13. That's it to create an object of student. After that, if we have to create another object, let's say S2, we can simply do student S2 equals to S1. So this will actually, copy all the values from S1 to S2 and thus the student S1 will be able to create a copy of its own which is S2. Now if you do a student which is like S2 dot set GPA dot 3.2, then it will also change the GPA of S2 which will become 3.2. So you see how the references, we have actually created two references, but the data that they share is common and the references that they share, that is the actual object that they share, is common. Although the name is different, S1 and S2. Now this is, in a way we are copying the references. The object reference get copied. But what if we want to make actual copy of an object? Well, in Java, the most elegant way to use the clone method is to inherit from the object class and use it like this, which is s1 dot clone and then create your s2 object. So this actually creates the copy of s1 to s2. So simply, by doing this, it will create a shallow copy. So what is shallow copy? Well, shallow copy is something in which all the primitive types get copied, but all the references type, like object type, do share common reference. So let's say in this case, student is only having primitive types, that is a string, then probably a name, which is Jim, and 3.13 is a float. So all these, considering all these are primitives, so they can be easily copied as a different object in S2. And in this case, if you try to change the values of S1, the values of S2 won't get changed because they form a different copy. Well, there is also a concept of deep cloning that also copies your objects. But then you see, like when we say deep cloning, then there is a different mechanism of doing that. But obviously, you have to use clone method. But we'll see what is shallow cloning and what is deep cloning maybe in our cloning tutorial. As of now, let's see the object clone method. So this is how the object clone method is defined. So you see we are having protected native object clone which throws clone not supported exception. So in this case, you see it's a protected method and also it's a native method defined in object class. It returns the object. The name of method is clone and it does throws clone not supported exception. Fine. So since we have seen clone method is protected in object class, so that's why it need to follow the rules of the protected method while doing the inheritance. Then to use the clone method, you must override in your subclass to upgrade the visibility to public. Because otherwise, if you just gonna, use the inherited clone method, you can make sure and you have to make sure that it is only used in a package and it is following all the, the visibility that a protected modifier follows. But if you want to make it your own clone method, it is always advisable to change it to public so that you can upgrade its visibility even outside your class, even more than outside the package and in your outside your derived, you can say, scope also. Now we'll see another way, like another things about clone, that is in cloning, any class that uses clone must implement the clonable interface. So clonable interface is a marker interface. Okay, and although it does not contain any methods, but whichever class need to override clone method must implement clonable interface so that your class actually knows that you're actually trying to clone or you're trying to use the clone method to clone your objects. Now the method that needs to be implemented is inherited from the object. So you have to write the definition as same, although you're overriding it, so you can, slightly change the protected to public, but you should keep rest of your signature as it is. Now clone also throws clone not supported exception, where the reason is because if you are not making your class implement clonable interface, then it will throw clone not supported exception. Because clonable interface actually marks your class to be eligible for cloning. If you don't do that, then your compiler will not know that it can use clone method. And if you try to use clone method without implementing clonable, it will throw clone not supported exception. Therefore, it's mandatory to implement clone not supported exception for cloning. Now let's see immutable objects. So what are immutable objects? Well, a special class of object is called immutable because their state cannot be changed once set. Some of the common examples of immutable objects are string, integer, etc. That means once you have set their state, it will remain as it is, it cannot be changed. So now, immutable objects simplify programming in certain instances, such as when writing the thread-safe code. So that means immutable objects simplify programming in certain instances. Fine. Because when you write a thread-safe code, you need objects that are thread-safe and which are immutable so that their state cannot be changed, and thus immutable objects actually make your code as thread-safe. They also simplify cloning since an object that cannot be changed does not really need to be deep copied. Fine. So even if you are not doing a deep copy, even if you are doing a shallow copy on an object, there still won't be a problem in immutable object because they actually cannot be changed. Now let's see some additional clone properties. So note that the typical clone properties, but they're not strictly required, but we typically say that it should be this way. That is like, x dot clone is never equals to x because these are two different objects. Fine. So this is something that should be there. Other things are like x dot clone dot get class double equals to x dot get class. So this is true because here, no, their classes are same with the object that you are cloning. So even the cloned object and the original object will have the same class. The third one is x dot clone equals x. So if you check it from equals, because equals actually checks only for the values, right? In case of string. So in this case, like it will give you true for x dot clone equals x. Okay. So finally, though no one really cares, but object does not support clone because if you just simply do cloning, it will give you a shallow cloning. So you have to override your clone method to do a deep cloning. Now, another important method in the object class is toString method. Now, this is really very important methods and it's highly used. In fact, in most of your simple code also, you should override this method so that you can use it and make it beneficial according to your purpose. So you see, this is the original implementation of toString method in the object class. So this is a public method and it returns a string. ToString is the name of a method and there's a simple return statement in it. So what it is returning? It is returning class name, okay, then at the rate, and then it's returning some hash code of the object by converting it to a hex string using integer dot to hex string. So this is how the originally toString method works. So you must have seen sometimes if you create your own object and you just try to call toString on that, then it gives you a typical kind of string in your console which does look as a garbage, but it is not garbage. Rather, it's your class name followed by the hex code, that is the hex string of your hex code. Well, in the object class, the toString method returns string. So it is intended to return a readable textual representation of object upon call. Well, it's really great for debugging because you can override and you can actually use it to print the values of all the data members in your class because toString would be able to access all the data members so that you can use it that way. So the best way to think of this is using a print statement. Just consider, you have to print your object and you have to print like every values of your object. Then if you simply write system.out.println and you pass your object to that, then your toString method will be called and your toString method, whatever implementation you have given, it will be executed and your object's data will be printed according to your own. So now let's see some meaningful info about some object. You can see that by default toString prints the total garbage that no one actually is interested in, say class name and then some hex string. But we actually don't need to do anything with that. Rather, we want some implementation where we could actually print our data members values and we can see that what all my object is having actually, the data that it is having actually that I have inserted. Okay. So by convention, print some simple formatted list of fields name and then values. Okay. The intent is not to over format, so we do not need to, put fancy spaces. We can just simply print it. And it is typically used for debugging so that in our debug logs can easily identify what this object contains, what data it contains. So that's why it's really beneficial to override the toString method. Now we have equals method. Well, when we talk about equals method, so this is the actual definition that is provided in your object class for the equals method. So it's public boolean equals and it does take object as a parameter and it returns this double equals to object. So you see internally the equals method of object is actually using double equals to. So originally the equals method also checks for the references. But in string class we say that equals method do check for the values. That's because in string class we have overridden the equals method to only check for the values. Okay. Now, this equals indicates whether some other object is equal to this one on a non-null object reference. It compares the memory reference. It is generally necessary to override the hashcode method whenever this method is overridden. So whenever we override equals method, it is always necessary to even override the hashcode. Why so? Because there is a contract between the two, and we'll see what's the contract shortly. Now, as to maintain the general contract that is between hashcode and equals, which states that equal object must have equal hashcode. Well, it's a simple statement. We'll see it in detail shortly. Now recall the Boolean double equals to method that compares when applied to object, and it actually compares the references. That is, the two objects are same if they point to the same memory. Now since Java does not support operator overloading, so therefore you cannot change this operator. However, there is a equal method of object class that gives you a chance to more meaningful comparison of objects in a given class. Let's say you just want to compare your objects by their data, and if the data is same in the two objects, then you should declare it equal according to your own implementation. In that case, you could override your equal method to just compare the data, and instead of comparing it by double equals to, just use equals method primitive data type, like comparing the string and integers, and then you can just override according to what you want to do with the equals method. Now to override, simply override method with the version that does more meaningful test, that is compare and returns true if equals false or otherwise. As with any other method that you override, to do so properly, you must obey the contracts that go beyond interface matching. Fine. With equals, the extra conditions that must be met are discussed on the next slide. So let's see what are the extra conditions in equals. Well, we have four properties of equals method. First one is that it is reflexive. That means for any reference value x equals x should return true. Fine. So that means it should return true. Then we have it as symmetric. That means for any references, the values x and y, x equals y should return true if and only if y equals x returns true. So that means it is transitive. So I think these are the properties that you must have studied in your maths, because these are actually widely used in the maths. So it is also can be applied to equals. Now it is also transitive. That means for any reference value x, y, and z, if x equals y return true and y equals z returns true, then x equals z should return true. So you see, this is a transitive property. Then we have it is consistent. That means for any reference value x and y, multiple invocation of x equals y consistently returns true or consistently returns false, provided no information used in equals comparison on other object is modified. Fine, so this is a consistent property. Now for any non-null reference value x equals null should return false. Okay, so it should return false. Now let's see the hashcode method. So we have seen equals method. Now let's see the hashcode method. Well, hashcode is like public native int hashcode. So this is a definition, original definition in the object class. So it's not definition, but it's just the signature of the method. Then Java provides all objects with the ability to generate a hashcode. By default, the hashing algorithm is typically based on an integer representation of Java addresses. Fine. This method is supported for the use of java.util.hashtable, and that's with that it is very commonly used. Nowadays, you can see that we are also using other data structures, but yeah, hash table was something that we were using. Now we discuss hash table like when we study collections, but as of now, you can say like hash code is algorithm which is used to return an integer representation of Java addresses. Now let's see the contract between equals and hashcode. So let's see what are the rules of overriding hashcode. So whenever invoked on the same method more than once, the hashcode method must return the same integer, provided no information is used in equals comparison on the object is modified. So when we say the two objects are same, that means your hashcode method must return the same integer, and provided no information used in equals comparison on object is modified. So you should not modify your equals method. Fine. The second rule is if two objects are equal according to equals object method, then calling the hashcode method on each of the two objects must produce the same integer result. After that, it is not required that if two objects are unequal according to equals method, then calling the hashcode method on each of the two objects must produce distinct integer result. However, the programmer should be aware that the producing distinct integer result for unequal objects may improve the performance of hash table. Now these are the rules, but there is also a contract. The contract says that if the equals method has returned true, that means the objects are equal according to the equals method, then the object should also be equal according to the hashcode method. So you should always maintain this contract by overriding these methods. And the second one is like if the equal method has written false, that means the objects are not equal according to the equals method, then you can or cannot, it's not compulsory that the hash code should return true. So hash code might return false as well. So it's always guaranteed when equals method is true, then hash code will always return true. This is the only guaranteed thing. Now let's come to the finalize method. Well, it is called as a final step when object is no longer used and just before garbage collection it is called. Okay, so it's a step to clean up your resources. Object version does nothing since Java has automatic garbage collection. Finalize does not need to be overridden, reclaim memory, and it can be used to reclaim other resources like flow streams, database connection, and threads. However, it is strongly recommended not to rely on this scared resource but explicitly create your own dispose method. So this was about the finalize method. Okay guys, thank you. This is about the object classes. We have already studied wait, notify and notify all while studying the threads. Thank you.